impact finds from the Large Hadron Collider? That would be a good question to ask him. Also, we do have Horizon. We'll ask him. We'll ask him. You guys can ask this guy.
It's happening.
Oh my God! Do you hear him?
We can all be heard. How do I adjust this thing?
Let me configure my stuff too. Because...
Oh, you're cutting out like crazy though.
Am I?
Yeah, it's probably my fault.
I would think it's your fault.
It's very much my fault.
This is the Dr. Paul, guys.
Who is that? Who is that guy? Just random guys showing up in the stream. No, don't mind me.
Just random people just enter into the stream.
and you just like, because you have like a secret Zoom number, and you just anyone who knows the number, they can just call in at any time and just drop in and start talking.
Yeah, and I've done that accidentally. I gave the wrong number to Katie Mack. And it was Dr. Pamela's, and Dr. Pamela had something going on.
Nice.
And so I was like, so Katie Mack was like sitting in Dr. Pamela's meeting, and I was like, did anybody say anything? Yeah, she was like, I just sat there.
like Pamela's office hours, and then Katie's like, actually, I had a question about number 4.
Yeah, excuse me, please. Excuse me. It was so great. It was so funny. I'm like, I'm sorry, because I get those. I had the wrong ID mixed up with my own room. Pro streamer.
This is like first world streamer problems.
I know. It was really bad. But what I want to open with first, if you don't mind, someone actually asked me about
so we're just going to jump in. We're not even going to have a repartee or...
Well, no, we are.
Warming up.
We are, but I want to talk about what's going on Thursday. I want you to tell...
Oh, my gosh.
Mm-hmm. Yeah.
I think the world is going to have its mind blown.
I think so, too.
Because... and it will be the very last episode of Space Radio, that's for sure. They're going to pull us off the air because of what's about to go down. So this is so cool. Like, you're coming on my radio show.
Mm-hmm. Mm-hmm.
And we're going to chat. I'm going to interview you about your life and work. We're going to talk about some of the latest news. We're going to take questions from the live stream and even callers, because we have a call-in system.
Mm-hmm.
And it's all going to happen in 24 minutes and 13 seconds. And it's going to go out on the air. It's going to be broadcast on public radio in Columbus, Ohio.
There you guys go. On the radio.
Yeah. And it'll be live on Twitch, on my Twitch channel, which has
we have
like 12 people. And so all 12 of those, that's going to be a very special dozen. And it's going to be simulcast on YouTube. It'll be released as a podcast, the whole deal.
Guys, there's his Twitch. Please give him more than 12 followers.
AMR FM, it's FM, WCBE 90.5 FM.
There you go. You hear that?
No, you'll get the radio voice. That's for sure.
Yeah. And I have no idea. I actually was going to ask you. We should probably talk a little bit more about the logistics, because I think we can do that.
We're gonna wing it.
But okay, because I think I gave everybody the wrong time. I said 3-ish, but it's fine.
Yeah. If 3-ish plus or minus 2 hours, close enough.
If they're in my Discord, or if they follow Twitter, then they'll know, because then I can correct myself.
And we'll be announcing it too. We are recording your show at 4:30 p.m. Eastern.
Right. So that's 2 my time.
2:30.
2:30, 4:30.
Unless you're in one of those weird half zones. Like, was it India? India's in a half time zone?
Yeah. India has that weird, and then here in our own, we have Arizona that just doesn't observe at all. No daylight savings. Arizona,
which I think is the right move.
I do too.
That's the wave of the future.
Yeah. No, it's so much better to not even have this be an issue. But consumerism, yay. So there's gonna be another cosmic event that I'm gonna miss because I'm gonna be playing video games like a loser. Shut up, Master Steel.
You can play video games like a loser and simultaneously listen to live broadcast also like a loser.
That's what people do with my stream. They're like, I'm playing Fortnite, but I have you in the background, and that's a huge compliment. I love it.
No, people say, like, I go to sleep with your YouTube videos on, and then they follow it up with, I mean that as a compliment.
Yeah. No, I told Dr. Pamela that, because she has that, You know,
She is the voice of a choir of angels.
Yeah,
Oh
it's
my,
just
I
when
cannot
she's
believe it.
when she's
It
talking
is.
about it,
Oh my,
just like this.
I can't.
How are you doing,
It's
Fraser?
be even better than that.
I
Like,
know. I can't even do it. I
no,
know.
it's like the angel Gabriel
Yeah.
is a physicist
Mm-hmm.
and is speaking truths not into our ears, but into our hearts.
Right. And it's all about astronomy. And so I'm just sitting there. I'm like,
And she's super smart and very articulate and is able to answer any question you throw at her.
Yeah. And it's hard because like her voice like makes me want to fall asleep because it's so soothing, but there's so much good information. So I usually have to listen to Astronomy Cast like 5 or 6 times, like one episode. Yep.
She's good.
I know.
She's good.
It's worth it though.
It's worth it.
It's so worth it. But she has a very soothing voice. And let's see, this guy. There's one guy in here that just keeps asking how much you can bench.
How much can I bench?
Yeah.
25.
Yeah.
Yeah.
Yeah, there you go. That's not even the bar.
I got permits. For these.
That's not even the bar, guys.
See, my shirt is down because Ohio, I have a close carry permit.
And then he goes, how much can you bench like a bro and listen to science mumbo jumbo? I don't even know what that last part means. I don't even really know what that whole comment means. That's why I never answered. I'm sorry. I was filtering.
About benching. But now you focused on it.
Yes. We need an ASMR. No. Nope.
Yeah. No.
Nope.
The black hole orbits the red giant.
And
this
then
Roche lobe overfilling with material until it funnels down to the event horizon, traveling at close to the speed of light. I can keep going. Maybe that's going to be my thing.
You should. I'm sure a lot of people would be really happy about me doing that, but I feel like that's a real sellout move for me.
Do I have a good ASMR voice? Not my radio voice. That's like the antithesis of ASMR.
Well, right now you're still a customer service representative.
Very much.
You're still a CSR.
I love it.
But you know, when we get you better headphones and what kind of
microphone?
Yeah,
once I upgrade. What is this? I told you this is the second cheapest headset on Amazon.
That you have for the podcast.
Oh, so for my podcast for Ask a Spaceman, I have a Blue Yeti that's very, very good.
Yeah.
And then for the radio show, it's in a like professional radio station. So there's a Shure microphone.
Yeah.
It's hooked up to a board and there's an engineer there. Greg Mobius, my producer and engineer, great guy. It sounds great. Yeah. Way better than this.
Right. And so CSR ASMR. Man,
I like it.
I do too. I feel like that's not even been tapped into yet.
How can I help you with your tech support issue? Have you tried restarting it? I need you to push down on the power button and hold.
Is your computer plugged in? But there we go. So guys, I think Joe, you made a command for the space radio stuff. I'll be tweeting that out too on Thursday. And you guys might see me right before it too. I'm trying to do an earlier stream that day, and then I'll hop over to that. And then I got to go mom. So it's how that works.
It's real life.
Yeah, there's been a lot of that lately. So, please turn it off and on again.
Please turn it off and on again.
Thank you, Faith.
Actually, I have no idea what ASMR sounds like. I've only read about it.
Yeah, it's like. And then people are like, whoa.
Oh, a lot of breathing.
Yeah. Well, no, that was me just like scratching it. Yes.
Am I just... No?
I would not pay you anything.
Oh, that hurt.
Yeah, no, it's very I walk into streams with it, and then it's like one of those things where I virtually like walk back really slowly because I just feel so awkward. Like I kind of want to slide under my desk and not like I don't know. It's a thing. It's a weird, very, very yeah, that was a Tyler one. That was totally Tyler one. There's tons of way to get that. So I have a sound machine. I don't know what happened to people just having sound machines. But
like to help you sleep at night, like a little baby.
Yeah, but no, it has like the sound of Jupiter.
Oh, like radio emissions.
Yeah, Has a whole bunch of different things. Is that a Jupiter? Is that a Jupiter bird call?
Yes. That's how Voyager and Juno and Galileo were all able to find Jupiter, because space is big, right? And even though Jupiter is the largest planet, it's puny compared to space, so it has to go find it. And so it sends out the radio signal call, the mating call, and it waits in one spot about the right orbit where we think its natural habitat is, and eventually Jupiter will respond, and that's how they find it.
Someone just said Jupiter sounds a bit creepy. It really does. It does. It sounds very ominous. It does.
Yeah, well, as those giant hurricanes.
Yeah.
A lot of ammonia. There's metallic hydrogen. We don't even know what's in the core.
Yeah. We were pretty sure it has a core, right?
Well, everything has a middle.
Yeah, a center.
We're pretty sure it's solid, but we're not 100% sure. Hopefully Juno will shed some more light on that.
Yeah, because if it does have one, it's pretty far down there.
Way down.
Yeah, like way down.
Like even more.
Yeah. And there's enough pressure in its atmosphere to make something called metallic hydrogen.
Which is cool.
Which is so cool. Which is super cool. So actually someone started off by asking me a question if there is any new finds with the LHC, so the Large Hadron Collider, if anybody's not aware of that.
The most annoying thing that the Large Hadron Collider is doing is not finding anything. It's super annoying. So we found the Higgs boson, pretty much where we expected. And that locked in the standard model, and everyone's like, yay, the standard model is verified. Good thing, because we've been using it for 5 decades. And then it's got nothing past that. No new particles, no interesting new resonances, no hints of anything moving beyond the standard model, which is making the particle physicists a little bit worried, because all of our extensions, or our most promising extensions past the standard model, were based on this idea called supersymmetry. And all of the simplest supersymmetric models are now ruled out because of lack of observations at the LHC. And so we're at a crossroads, like, is supersymmetry still the way to go? But then we have to go to these really uglier and more ungainly versions. Or is it something else? But we kind of haven't been working on anything else seriously for like 20 years. So what do we do now?
And just to follow up, in Winter, I'm going to get to that question, because that's not a stupid question. Faring says, what are chances of supersymmetry now?
Low to extremely low. I mean, supersymmetry could still be a viable theory of nature, but it's not the simplest versions, which we were hoping to make the easiest jumps from the standard model into something new. All those are now ruled out. It's only the more complicated versions, which the whole appeal of supersymmetry was that it was mathematically simple, had these really elegant mathematical properties. All those are gone now. So it's like, what gives?
Yeah. Oh, yeah, no. Yeah, see, El Jefe says, Winter, that's actually a question I'd like to know. So, yeah, not super quick. Yeah, because a lot of people, I had to have a rant last week. Sorry, I'm kind of tangenting about, I get asked a lot of very, very difficult questions, like, how do quarks work? Let's talk about bosons, gravitons, all these things. And I'm like, guys.
On and on.
Like, this is really, really tough to do. And I tried to sit down and, I mean, you've seen my notes. I've showed them to you several times, but talking about things and then getting sidetracked with these, tell us more about quarks and how they work and everything. And I'm like, guys, I can't like keep up with this. Like, I do this for 4 hours and my brain is done afterwards. I try my best, but then I get people that, will be like, well, let me answer that for you. Or you got that wrong. And
right.
It's,
yeah.
You're going to make mistakes and get confused, especially when I get flustered. Like, if I start getting bothered by something, then I'll be like, okay, well, there goes,
Oh, yeah, for sure. Because you can get in a zone. I noticed this with my radio show. So last week, The audio going out to the stream was bad,
Oh
but I couldn't hear
God.
it. Like it was fine in my headphones. It was fine in the booth. Like, and our recording was great, but for whatever reason, the one going out to stream sounded really, really bad.
Yeah.
And that's all people talked about.
Yep.
And so I was trying to focus on like the news and like my notes for the show are like one sentence for each topic and then just riff on it. And I was like getting in the zone, and then I'd look to the chats and be like, your sound sucks. Why don't you fix your sound? Oh my gosh, the sound, you were at the bottom of a well and all this. And it kept pulling me out. And I think the quality of the show suffered.
Oh yeah.
And live Q&As. So you are actually doing one of the hardest things in science communication, which is science improv.
It feels like it.
Which is exactly so you're getting random questions on random topics that you have no idea where they're going to come from, what they're going to be. Your audience is constantly changing in terms of what they already know and their expectations and their background and their desires for learning more.
Right.
So you're trying to come up with a question or come up with an answer, tell it, get the right information across at the right level, and tell an interesting story to keep it entertaining.
Exactly.
Simultaneously. This actually love doing spontaneous Q&As like this because it's the most difficult form of science communication. And I get a kick out of it.
Me
Plus
too.
I don't have to do any prep work.
Right. Oh yeah. If I don't have to do prep work, but like if I get a big host from a, streamer or something, like I thrive off of that. Like I love it. I'm like, let's go, because I'm going to get a lot of the questions like, how do black holes work? How big is our galaxy? Can we look at Jupiter? Can we look at Pluto? Which no one ever says. I'm kidding. But no, but like, can we survive on Mars? What do you think? Like, I can talk about these topics, but then I'll get someone that will be like, can you explain? And I can clearly tell that this person,
and that's their voice.
That's how they sound in my head. Like every single time
that's how they sound in real life. Let's be honest.
Yeah. And I'm sure that they drink their beverages, pinkies out, but I'm like, well, hold on, let me try to stay with this. 'Cause people are coming in and out. Like you said, the audience is constantly changing. So I try to prep the community, and I have an amazing community. But I have to kind of repeat a lot of things a lot because there's new people coming in. Like Winter has a really good question, and we can go with that because it's one that I would love to hear your answer on it. I'm going to actually I'm going to take it as a 2-part because I'm going to put in my own question with it. But yeah, like there's some basic ones that are very, very good. And a lot of people are scared to ask that. And especially if you get the people that come in that want to know about quarks. And I'm talking about black holes and how we have these stars that move around our supermassive black hole in the center of our galaxy. And someone's like, well, talk about quarks. And I'm like, okay. Right.
Like,
and I could have like 10 good questions that I could answer about our supermassive black hole, but they go away because now there's people feeling like, well, I'm not smart enough for this stream. I don't want to ask my basic questions.
We are not dodging the question. We're actually, Master Seal, we're not dodging. I'll talk about what is supersymmetry. But this is a really interesting point. And something that happened last week, I think last week I was talking about how supernova go off. And a lot of people said like, oh, wow, that was over my head. And I felt bad about that. Like, and that was a failure on my part. If I go into too many details or I miss the mark in terms of how much do I explain or how long or short is my answer, how many details, how surface level. And so I rely on that kind of feedback for someone to say like, that was over my head. I didn't get it. That means I missed the mark. I didn't gauge the level necessary for that particular question, that particular audience. And you constantly need that feedback because you're constantly adapting to what your audience is giving you.
Oh yeah. And like if I want to, like I know that when there's a lot of people, especially from, our community, or not our communities, your community, like the weekly space hangout, people that have been tuned into Astronomy Cast for so long because that podcast has been going on forever, and they're very knowledgeable and they're very helpful. But sometimes, that they take their expertise, and when I'm trying to live stream and talk to a gaming platform, like this is a gaming platform. people don't come here to see this and talk about this, but I'd like to do it because they're people I identify with, because I'm a gamer. And I'm not even that good, but I still, I enjoy video games, and I don't need to be the best. I just want to play video games. And so why not? And so I get a little concerned, just because, I don't want anybody feeling like, okay, so some guy, and now this is where we'll go now. We'll go into the topic that I was going to ask you, or not the topic, a question. What are the solar winds? And also, is there a difference, this is where I'm tacking this on, between CMEs, which are called coronal mass ejections? Anybody that doesn't know what CME means? And what's the difference between solar wind and CMEs?
Oh, okay. The solar wind is a constant rain of particles being ejected from the surface of the sun. Our sun is really hot. You may have noticed. It has a roiling, boiling surface. That surface is emitting light, which we can see. It's also emitting this constant drizzle of particles of charged elementary particles. We're talking about protons. We're talking about electrons that just flood the solar system. They're just always there. A coronal mass ejection is like the equivalent of a hurricane versus that light drizzle. It's where a piece of the sun's surface itself detaches due to the release of an enormous amount of magnetic energy in a very short amount of time. It detaches from the surface of the sun, launches itself into space at 10% the speed of light or so. These things are massive, and every once in a while they slam into planets.
Like ours.
Like the Earth.
And what happens then?
So these are giant storms of charged particles that also have an incredible amount of electromagnetic radiation associated with them because they're moving charged particles. And when that happens, we have to shut down our satellites. Otherwise, their delicate circuitry will get ruined. We have to bring astronauts inside the space station to get protected, and we will see massive geomagnetic storms on the Earth. Our aurora will get pushed down to more and more southern or equatorial latitudes. They'll be much stronger. Sometimes this electrical systems on the surface of the Earth itself can get affected, like power grids. Back in the 1800s, there was this massive event that electrocuted, or shocked telegraph operators.
Oh no!
This is called the Carrington event. It happened in 1868, I think, and it was the largest CME ever recorded. And it was noticed because telegraph operators around the world kept getting shocked that day. That kind of sucked.
Do we know if there's any kind of link between a CME and sunspots? Because we obviously know our sun has cycles, right? It has a solar minimum and a solar maximum, right? 11-year cycles.
Exactly. And so there is a link between sunspot activity and solar flare in CME activity. The more sunspots you see on the surface, the more twisted and tangled the sun's magnetic field is. Sometimes those magnetic fields can get so twisted and so tangled they snap like a rubber band. That releases the energy that powers a coronal mass ejection. If you're not seeing a lot of sunspots, that means the sun's magnetic field is nice and smooth and not all tangled up. So you don't have that opportunity to release a lot of energy to produce a CME.
Yeah. And I got asked that question. I thought, I missed those kind of questions because those are good ones. And so they can disturb radio communications. And that's very important to have, especially, like in the 50s and 60s and Cold War era. Don't want that messed with.
Oh yeah. Don't mess with the sun.
Yeah. You don't want communications messed with, period. So, the quiet sun, I think is it at a solar minimum right now? Because I know during the solar eclipse, when I was looking at it through my telescope, with a solar filter, guys, okay, I saw that it didn't have many sunspots.
Oh yeah, it was so boring.
It was.
I think there was one.
There was one. There was
like one little whoop, on the surface, and that was it.
Yeah, it was pretty boring. But someone else just asked a good question. Vacuum, you asked, is there Are there any planets in the universe that are not in the shape of a ball? So our planet's like there's really no perfect sphere in space, including stars, right?
Yeah, just because once you start adding rotation to anything, you're going to get deviations from perfect sphericity. But general vaguely ball-ish is the standard for a definition of a planet. If you're too small to have gravity make yourself round and you're all lumpy, then you don't qualify as a planet.
Yeah. Yeah, and so even stars, we do have some really. So Jupiter's pretty oblate.
Oblate, Saturn's I think the most oblate in the solar system.
Yeah, they're little fatties.
And then there are known stars that are rotating so quickly that they puff out in the middle.
Yeah, Jupiter, you can, I think, yeah, Saturn. I haven't really looked at Saturn. I pick on Jupiter more. As far as its
okay,
oblate.
we're gonna do an oblateness off.
Mm-hmm.
We're gonna look up Saturn oblateness.
Well, wait. Like, so I got that space engine thing up. So, I mean, it kind of. I'd have to wait. No, it is. Oh my God, it is. I never really noticed that. Did I win? Yeah, I mean, as far as like, I don't have the numbers on it actually, but.
I have a 10.097.
Mm-hmm.
So like a 10% flattening for Saturn.
Thick.
And
yeah. Sorry. Twitch talk, funny talk. Isn't Betelgeuse really misshapen?
I think it is.
It is, and it's also because it's, in the end of its life and it's stripping off those outer layers of its of what it is. And those outer gases are escaping due to it's losing mass. At this
we
point.
got 6.5% flattening for Jupiter.
Oh. And Saturn was what again?
Like Saturn was close to 10, so 50% more flatter.
More flatter.
More flatter.
More flatterer.
So you could have a flat Earth if you tried really, really hard.
Mm-hmm.
But actually, the Earth would probably rip itself apart before you got it.
Probably.
Significantly.
Probably.
Yeah.
And although, since we're talking about shapes, Saturn does have a really cool hexagon storm.
I love the hexagon. Love it.
It's on its north pole, correct?
On the North Pole.
Yeah.
Only
on the north.
Only hexagon in the solar system.
Yeah, right here. So obviously looks like I'm on the south, but it's okay. I can change. Up and down in space is a funny thing, guys. But yeah, right here, I actually can get that. So what causes this?
So with the North Pole of Saturn, what you have is basically a hurricane in the center. There's a spinning storm. And then as you go down further and further south out of that North Pole, the wind speeds slow down. So you have a region where fast winds rub up against slow winds, and that introduces what's called an instability, which generates a storm. And so at a certain latitude, coming down off the North Pole, you get storms appearing.
Mm-hmm.
And they can spontaneously form, and you'll get a certain number of them. You might get 4, you might get 10, just some number of storms will form in a loop. And because they're low pressure systems, they will repel away from each other. So those storms will separate themselves equally across that latitude, making that circle. And then what we're seeing is the hexagon is winds that are trying to move down. They get deflected by a cell of a storm, get passed on to the next storm, and then that storm pushes it up and around and around. So I imagine it like a bunch of people standing in a circle, passing a frisbee around themselves. And the frisbee, even though the people are standing in a circle, the frisbee follows straight lines that inscribe that circle. And why Saturn has 6 storms, making a hexagon instead of 4 storms or 20 storms, we think just has to do with the particular physics of that North Pole, of the wind speed and the temperature and the properties of the atmosphere, to just give it 6. instead of another number. But that's the basic physics.
And and we didn't really understand that. I mean, this was kind of a new thing that we understood this better, right?
Oh, yeah. So it was better imaging from Cassini, so we could get a map of the wind speeds at different latitudes. And we were able to do some laboratory experiments where we set up similar kinds of rotating fluids, obviously not recreating the Saturn atmosphere, but analogs to it, where we had rotating fluids with different speeds, introducing instability, seeing these vortices form, and then various geometric shapes spontaneously generate.
Yeah, someone just said, I can talk to you about the expanding universe, iguana. But someone said, Storm, does that mean that there's oxygen on the Saturn?
I don't think there's significant amounts of oxygen in the Saturn atmosphere. There is oxygen in the core, but most of Saturn is hydrogen and helium.
Mm-hmm. Same with Jupiter, but Saturn's a little bit weirder. Because
what's weirder?
So let's say I have a huge bathtub and I can put Saturn in it. Saturn would float, whereas if I had a bathtub big enough for Jupiter, Jupiter would not float.
Now, is this candlelit? Is there bubbles involved?
Yeah, I have a Carl Sagan candle. I think that we would probably have to have just at least, one of these going.
Okay, so it's a romantic bath. I'm just trying to set the scene. Like I had a dinner date with Saturn.
Yeah. Right. No, You'd have to have a Carl Sagan, prayer candle. That's how you say that word.
A votive candle, yeah.
Yes. But yeah, so Saturn would be buoyant, whereas Jupiter wouldn't. So do you want to try to tackle that?
Yeah, so if you just take the mass of Jupiter and the volume of Jupiter, it gives you a density. That density is less than the density of liquid water, which means it floats. And it would also mean it would leave rings in the bathtub.
Oh man. Yeah. And so Saturn's rings, though, that brings us to Saturn's rings. What's the Roche limit? How does this work?
Rings. So rings are a huge mystery because we're pretty sure the rings, by the way, are made of little bits of ice. It's like 99% pure water ice, which is why they're so shiny. And we're pretty sure the rings are old because the only time where you could get that much material in orbit around Jupiter to generate a ring was in the early solar system, when there was more stuff hanging around all the early protoplanets. But the rings look super sparkling brand new. You'd think over the course of billions of years, they would have gotten dusty and dirty. They will have picked up some grit, some micrometeorites. So the big puzzle is, why do they look new when we're pretty sure they're billions of years old? And that is an unsolved mystery of the universe.
Yep. But we know something called the Roche limit.
Right. So the Roche limit is if you take something orbiting something else, like a moon orbiting a planet, and you bring that moon closer and closer and closer, eventually there'll be enough differences in gravity between different points on that moon that those differences in gravity will overwhelm the chemical bonds that glue the planet together, and it'll get ripped to shreds. So if you were to take a small moon-sized object, put it close enough to Jupiter, eventually it will shred itself up and give Jupiter a bunch of rings. Same thing for the Earth, same thing for the Sun. I believe one of the moons of Mars is slowly spiraling in, and in 10 million years or something, it will get within the Roche limit of Mars and it will get shredded apart.
Hopefully,
because screw those moons. Why? Like, why?
I know. They're we were looking at them. I was with Dr. Pamela. I was like, this one's clearly a cashew, These are technically, I would be fine saying captured asteroids.
It really is. I mean, it's not a moon. I mean, come on, Mars. You're not
No.
It's like Mars sees Earth with a big moon, is super jealous, and goes and grabs a couple asteroids just so he can say, "Hey guys, I have 2 moons."
Yeah.
But everyone sees right through that.
Yeah, and also one of those moons is likely going to fall directly towards it, and hopefully it
can't
does.
even hold on to it.
Exactly.
What a joke.
I know.
What a joke, Mars.
Yeah, Mars.
No one takes you seriously anymore, except for Elon Musk.
I know, and all the other people out there that are really rooting for that. But so the Roche limit is a thing, but there's something else I'm trying to think of what that was. Oh, what did you say towards the end there? Because it led on to another question about rings, things getting torn apart. I
made a bathtub joke.
Yeah, I'm not remembering it. It's not coming back to me. Someone asked, since we're kind of talking about our solar system, how does Mercury retrograde happen? It's an optical illusion.
Mercury is the most screwed over planet in the solar system.
Yes.
It's really close to the sun, but it is so heavily influenced by the orbits of all the other planets, most especially Jupiter, that it doesn't get to live its own life. Because of constant interactions with Jupiter, it's not quite in a resonance with perfect resonance with the sun. It's in this weird 3-2 thing. It has weird orbital properties. It's especially eccentric. The eccentricity precesses around the sun. It's like people just need to leave Mercury alone.
Yeah. It confused, I believe, Newton. Newton was really confused by Mercury.
So everyone's confused by Mercury. It was a known, the big triumph of Newton's laws of Newton's gravity was the ability to, with just one simple equation, predict the motions of the planets. And that's how it's thought, like, wow, gravity is universal. Isn't this pretty cool? Newton's pretty smart. And he was aware that he couldn't 100% explain the orbit of Mercury. And at the time, everyone's like, well, you're close enough. We'll take it. Maybe we just don't understand all the interactions happening in the solar system. And over the course of the 1800s, every once in a while, people would come back to this problem of like, what's going on with the orbit of Mercury? And they would add more nuances into the equations, include more effects like from the gravitational effects of Jupiter, et cetera, et cetera. And it was never quite able. Newtonian gravity was never quite able to fully explain the orbit of Mercury. It wasn't like a burning problem in astronomy. Even when we get into the 1900s, everyone's just like, yeah, it's probably something. We're missing something. We forgot to carry the 2. We had a math.
Infinity. Infinity. Yeah. Just throw down the infinity.
Maybe infinity. Maybe it's magnetic fields. I don't know.
Magnetic fields. Who knows?
It's like, we'll figure it out someday. But we got better problems to worry about. Like, hey, what's going on with the Andromeda Nebula? And Einstein, when he developed relativity, one of the first things he seized on was the fact that with his new theory of gravity, he was able to 100% exactly explain the orbit of Mercury. And that was a sign to him that he was onto something big. And of course, it was included in his original publication. It's like, hey, by the way, this long-standing, centuries-old problem that everyone just kept shoving under the rug, I solved it.
Yeah. Someone just said Mercury is closer to the sun, but it's cooler than Venus. Actually, that's a half-truth. Half of it is cooler than Venus. Mm-hmm. Well, I mean, half of it's very cold. Yeah, half of it's very cold. But the other side of it's pretty damn hot. Pretty damn hot. But not as hot as Venus, because Venus is trapping in its gases, its greenhouse gases. We actually call it a runaway greenhouse effect. Take lessons from that, because you don't want that to happen to Earth. It's already happening, guys.
Yep.
So one side of Mercury is very, very cold. And ice can even build up back there. Haven't we seen that?
Yeah, I believe so. So I think there's ice on the dark side of Mercury, but eventually it does rotate around. It's not in that perfect resonance where the same face always faces the sun. Yeah. So it does eventually rotate, and it gets a turn in the Friar. Venus is so hot. I may be misremembering this, but we're live, so I'm just going to go with it. Once the runaway, we think Venus used to have plate tectonics, but then it got so hot on the surface that it actually shut down tectonic activity.
So it became not geologically active.
Right.
Oh man.
I think that's true.
Yeah, well, there actually there's been a lot of stuff coming out on Venus that, you know, the clouds might be habitable. Like, have you heard that?
Yeah. So if you go in a certain altitude, then it's somewhat air pressure-ish with somewhat the right temperature. It's pure poisonous carbon dioxide, but hey, can't get it all.
Yeah.
So yeah, maybe you could put a cloud city in Venus, and the winds are like hundreds of miles per hour.
Yeah, and it rains sulfuric acid, so who cares?
Yeah, I mean,
it's just gonna burn your skin off. It's fine though.
It's about like Columbus. So
it's just a flesh wound.
Yeah.
So someone said, so would Mercury be the worst planet to inhabit? So obviously you can see on my screen right here, it's pretty marked, right? Because it has no atmosphere, and the sun is like a huge magnet for asteroids and stuff that come in close, and this guy obviously has taken a big hit. What would you think, Dr. Paul, would be the worst planet to inhabit?
Geez, it's like worst planet is a tie between every planet.
Wait, hold on. Your sound just sounds like you actually fell into Jupiter. Wait.
I did.
You did? Maybe check the cord connection.
Well, I haven't touched the cord. The cord's like this. I'll do it. It's probably just the crappy university Wi-Fi.
Oh, it's okay. So we're going to imagine you're falling in Jupiter because you would get crushed. Just like your sound.
Yeah, it would suck. Do I sound any better now?
No.
Oh my God.
you sound like you're talking like this. No, like you've got like you're talking into a pillow.
Oh, like I'm trying to suffocate myself.
Yeah, you learned you're going to Jupiter. It's not going to work out well.
Okay, so what I'm going to do is I'm going to switch headsets.
Okay.
Maybe that'll be it.
Maybe
I should have bought the third cheapest headset on Amazon.
So, guys, I would wait.
The microphone?
Right. It's going to be, let's see.
All right.
Let's see. Yeah, it's probably the connection.
That sucks.
It's okay though.
I can't believe this is like, multi-$100 million a year institution, and the Wi-Fi sucks all through campus.
All that money made by textbooks.
Yeah, we gotta put it in the rec center.
But this is good. I feel like this is very role playsy for maybe the worst planet in our solar system to live on. I feel like your voice matches this, so the immersion is. Wait, say something again.
What?
Oh man, no, I had hope for a second, but it's okay. Christmas ruined.
All the planets suck for habitability for all their own unique special reasons. There's no winning.
LARPing on Mercury. Yes, Westworld rustic charm. I feel like this is great. Yeah, it's probably a connection issue, but I think it's fine for the most part. Like everybody in here, guys, he's only here for another 15 minutes. I think everybody's gonna be okay.
We can suffer through this together.
Although I must say, I think your headphones were better, as far as a better pillow to be talking into.
What if I do both? Does that does that help?
You can't amplify by sheer quantity.
Oh, it's not how that works?
No. We understand. It's fine. Yeah.
Yeah, there's nowhere else I would live in the solar system. It's either too hot or too cold, too far away.
Yeah. Oh, and well, speaking of that, someone just said TRAPPIST 1D. I thought it was 1E that they thought was interesting. Recently.
One, who cares? Because we can never go there.
Right, because it's 40 light years away. How long would it take us with like modern day technology.
Oh, only like 100,000 years.
Yeah. Yeah.
Longer than the entire history of written civilization and probably humans as a species.
Yeah, I think it would definitely take, way past, wait, you said 100,000? Because I think going to Proxima Centauri system at like 35,000 miles an hour, I think would be like around, I always have to do like 67,000 years.
It's a long time.
Yeah.
So if you imagine our ancestors who just figured out, I don't know, bipedalism.
Right.
And that was the hot new trend.
Walking upright. Mm-hmm.
Like, wow, I could see so much. If they were able to launch a spacecraft, it would just now be reaching TRAPPIST-1.
Yeah.
Something like that. Like that, it's you have to think geologically, you have to think astronomically for these kinds of distance and time scales.
Joe said, do you have a cup and a piece of string at all, Paul? Mm-hmm. This is not Pee Wee Herman. Not with that attitude, someone says. Well, can you discuss and just because we're gonna like faster than light travel? Why?
Not a thing.
Yeah. Why not?
Sorry. Because relativity. I mean, Einstein said we can't do it. And are you going to tell Einstein he's wrong? I'm not.
No.
I've tried, and he gets really, really prickly.
Well, it's probably because you woke him from the dead and then just said
there was that too.
You're wrong. Goodbye.
He hung up. I'm not 100% sure it was Einstein, but he was very perturbed.
Mm-hmm. And go on about that though. So, I mean, some people really believe that faster than light travel, like there's a bunch of other things that they're trying to experiment with to get us closer to light speed, right? Different.
But even quote unquote closer, like the whole Starshot initiative is hoping to get something to 10% the speed of light, which itself is probably a pipe dream just energetically. Going faster than the speed of light using rockets and stuff is never going to be an option because you literally need an infinite amount of energy to go faster than the speed of light, and good luck finding an infinite amount of energy. And all the concoctions you try to make in general relativity, like wormholes or Alcubierre drives or whatever, always end up requiring exotic ingredients that simply don't exist in our universe and violate a whole bunch of other things that we know about the way the universe works that have been very, very well tested for centuries in some cases. So yes, in physics and science, technically anything is allowed. All of our knowledge is provisional based on current data. There could be an experiment or an observation tomorrow that turns everything on its head, but I'm not exactly losing sleep.
Right. And so do wormholes, you just got the holy grail of like 3 questions that I get asked a lot. Do wormholes exist? Do white holes exist? Oh my God, I don't think it's a trifecta.
Oh, it's a bifecta.
Yeah, it's just 2. I just got a twofer.
And can we go faster than the speed of light?
Okay, let's make it a trifecta. I'm good with that.
There's your try.
Thanks.
Yeah, no, and no. There's the trifecta of negativity. It's a triforce of no.
Oh,
right there.
Oh,
each one.
That's
is a no.
intense. Never
There's
heard of white holes.
A no, and a no.
Yeah, white holes don't exist. Warp
Not
drive.
in our universe.
No. Warp drive, no. What would happen with our bodies if it's possible to travel with the speed of light? Is it possible without dying?
No. Well, 1, it's not possible. And 2, as you go faster and faster, bad things start happening to you. Like, I don't know, the cosmic microwave background, which is right now just a bath of microwave photons left over from the early days of the Big Bang, get blue shifted to be X-rays and gamma rays, which, aren't pretty. And there's a whole bunch of hydrogen and helium just floating around minding its own business between the stars, traveling at 10,000 miles per hour. It's not a big deal. Traveling at close to the speed of light. Now you are a particle accelerator.
In and of yourself. Pretty. Yeah.
Like you become the the business end of a particle collider.
No bueno. Someone says, does dark matter interact with itself in other ways than with gravity?
We don't know. We honestly don't know if dark matter interacts with itself through the weak force or if it's completely invisible even to itself. That is a 100% open question.
Yeah, actually, I can just say that. Zoto says, don't you gain mass as you speed up? Yeah, you do, but it's pretty complex, actually. I mean, you could say that. You could say as you approach the speed of light, you require infinite energy because of that. But it's a little bit more. Do you want to try to tackle that?
Let me try to put it as simply as possible.
Mm-hmm.
We know that E equals mc squared, right?
Mm-hmm.
We're all on board with that?
Oh, yeah.
Okay. I can't see anyone else raising their hands, but I'm just assuming. I'm assuming they're
energy equals mass times the speed of light squared.
Right. So energy is mass. Mm-hmm. Mass is energy. Energy is mass. That's what that equation tells us. Mm-hmm. The c squared is just a conversion factor. Mm-hmm. It just tells you how much energy is in a little bit of mass. So any kind of energy is also mass, so including thermal energy, kinetic energy, you name it. So a hot cup of coffee has slightly more mass than a cold cup of coffee. All right?
Mm-hmm.
So far, so good?
Yep.
So a baseball sitting in my hands has a certain amount of mass.
Mm-hmm.
If I throw the baseball, it has its mass plus some kinetic energy because it's moving, which means it has a little bit more mass than the stationary baseball. To accelerate something to the speed of light, you keep building and building and building its kinetic energy, but since energy is mass, you're also building and building its total mass.
There you go. That's a good. So he threw in the word kinetic, which is why I was saying it was a little bit more complicated than just being like, by the way, you just add mass, but it is an add of. I mean, that's what happens. So can we harvest energies from black holes? Negative. What do you think about Dyson spheres? Speaking of harvesting energy,
don't make any sense.
Me neither. But I thought that was a vacuum first. I thought we like a dirt devil.
I love it. It's the new invention. Yeah, no, it's a thing. It's a Dyson sphere for heating homes.
Yeah.
Using complicated pipes.
And so why can't Dyson? Why can't we put a Dyson sphere right next? Okay, so like putting it right next to the sun and harvesting its energy.
So, one, in order to build a complete Dyson sphere, you need more material than is in a solar system.
Yeah.
So good luck.
That's hard.
Excuse me. And so you might. Okay, so you say, okay, instead of a Dyson sphere, it's going to be a Dyson swarm. It's going to be a bunch of panels. Mm-hmm. Or something.
Right.
And you put it up in orbit around the sun, and then light shines on one side, heats it up, and then you got the cold side exposed to space. And so there's a difference in heat, which means you can extract energy from it and do work and power, civilization. But what's going to happen with either a Dyson swarm or a Dyson sphere, however you construct it, is because the backside is also going to radiate heat because there has to be a flow of energy out of the system. You're not going to get all the energy that you think you're going to get. You don't capture all of the energy on the inside surface of the sphere. You capture the amount of energy you have available to actually do work is the difference in energy levels between the inside and outside edges. Mm-hmm. Which is determined by the thickness of your Dyson shell or your Dyson swarm or panel or whatever. And so you actually get way less energy than you think. And I'm guessing, I haven't run the math, I probably should one of these days. It's probably going to cost you more energy to move the stuff around to construct a Dyson sphere than it would be that you will ever actually extract from it.
Yeah.
So it might make for a great art installation.
Yeah, like something you would see at Burning Man or something.
Yeah, burning I was trying to think of like a Burning Man joke.
I know.
Like Burning Galaxy.
Burning
I don't know.
Sphere.
Burning Green Man. And and then we've gone out and looked for Dyson spheres, because if you completely enclose a star, then the Dyson sphere itself will glow in the infrared from all that waste heat.
Mm-hmm.
So we've looked, like, are there any stars or any sources of light in our galaxy that are only emitting in the infrared? The answer is no. And then we go out and say, okay, if a civilization were able to place a whole bunch of Dyson spheres throughout their galaxy, or multiple civilizations all building Dyson spheres, that will shift the entire spectrum of the galaxy to make it look more infrared. We've gone out using galaxy surveys to look for those signatures, found nothing. So nobody is building Dyson spheres. They're probably not building them for a very, very good reason.
Because you can't.
Because they're dumb.
Mm-hmm. Yes. And so Insider asked a really good question. I had to scroll up and pause chat to get to it. So how can it be that dark matter is the dominating kind of matter in the universe? Doesn't seem to influence shape of things through gravitational effects, orbits in our solar system, etc. Where is it hiding or accumulating? It is clumping together.
Right. Dark matter, we're pretty sure, according to our best guess as to what dark matter is, it does clump.
Yeah.
We're not sure yet how clumpy it is. So it does clump, at least on the scale of galaxies. So if you have a clump of dark matter, you have a galaxy embedded inside of it. Whether inside a galaxy dark matter is smooth peanut butter or chunky peanut butter, we honestly don't know. And if it's chunky peanut butter, we might be able to see some subtle effects in the motions of individual stars or through gravitational lensing, but our instrumentation isn't sophisticated enough to be able to tell that apart quite yet. So dark matter does clump. We don't know how small the clumps are.
But we know that it keeps our galaxy kind of intact, yeah?
Yes, so it at least clumps at galactic scales. It may clump down at even smaller scales, like solar system scales or molecular cloud scales, but we don't know that for sure yet.
Ooh, someone says, okay, so I knew if we talked about Dyson spheres that we'd get this question. So not bad, Iguana. I'm on the same wavelength. We've actually had Dr. Tabitha Boyajian on here before. So people say, okay, so Dyson spheres, we're going to talk about that. So we're going to obviously talk about Tabby Star.
Yeah, Tabby Star was nothing. Tabby Star was one of the least interesting astronomical stories to come out when it came out. It was very, very interesting. So basically the end result, Tabby Star, it's dust making the star look weird. And it was very interesting when that story broke to listen to what was going on in professional astronomy conversations versus what was going on in public conversation.
Mm-hmm.
The professional astronomy conversation was like, oh, that star is kind of weird. It's probably dust or something, but whatever. Okay. And that was it. And then move on to other topics. And the public conversation was totally different. It was like, maybe we see aliens and stuff. Not saying it's aliens, but maybe it's aliens. But it was like, that was like the last possible hypothesis in a long list of alternatives.
Mm-hmm.
And not even the most promising one, and even wouldn't be conclusive evidence for the existence of extraterrestrials around that system. And it just wasn't interesting at all. There's a lot of stars in our galaxy that we don't understand the properties of because we only see one or two examples.
Yeah.
And yeah.
And you're right about that, because I actually, when I had her on here, I was completely under the weather, so I wasn't able to moderate well at all. But yeah, it's one of my most downvoted or disliked videos on YouTube because I couldn't get her to say it was an alien megastructure.
Because she won't, because she knows it's not.
Right.
And she knew that when she wrote the paper. And her paper didn't even include megastructure stuff. It was some other people, I forget their names. I'm blanking on the names right now, that simultaneously wrote a paper that said, hey, let's say we want to build a Dyson sphere, but we're lazy or we're going over budget, whatever, and we only build part of a Dyson sphere, it would block the light in a certain particular pattern. Oh, hey, look, there's Boyajian star that block where the light dims in a particular pattern. Maybe it could be a megastructure.
Yeah.
And I took issue with that specific paper. Once you introduce intelligent agencies who are able to craft whatever structures they want for whatever reason they want, you can replicate any signal. So if you look, so that hypothesis had no predictive power because the partial Dyson sphere could be, a bunch of slats like a window blind, and that would give a particular signal. Oh, no. Maybe it could be a bunch of hexagons arranged like a honeycomb. That would give a particular signal. Oh, maybe it's triangles placed equatorially, and that would give a particular signal. You could generate any kind of pattern of light dimming you could ever want, which means I haven't explained jack squat.
Right. So why would advanced civilizations take any interest in Earth and humans? I personally don't think they would. If they were able to actually get to our solar system, they'd probably be like, move on. But that's all conjecture. That's all opinion. What do you think?
I mean,
do you think
the energetic requirements to go from system to system are so ridiculously high, and they're actually so unfathomably high that it's so easy to sweep it under the rug, where you can just think, oh, if we do this or this, we'll go to another stars. No, it requires capturing our solar output for 1 million years before you get enough energy to feasibly transport a 1-ton payload to another star system. Like, just the energetics and the time scales and the distance scales are so astronomically huge, and I feel like that doesn't get enough respect in these kinds of discussions.
Oh yeah, no, and that's exactly it. So it's not that people in astronomy don't believe that there's other life out there. I like to tear it apart with saying things like, well, it's probably not going to be like how we know it. We only know our experience, and we're a result of our environment, right?
Mm-hmm.
And also, like, again, like you said, taking in how our nearest star, other than our own, is 4.2 light years away. And again, with modern day technology that we have, that's 4.2 light years going 35,000 miles per hour would take somewhere around like 77, not 78, 67.
A long freaking time.
Yeah, 67,000 years to go 4.2 light years. And I just spit everywhere saying that because it makes me, it's one of those things that people just don't really, they don't really think about it, and when you're traveling these vast distances, and that's just our next door neighbor star. So when people go,
preach it, sister.
Yeah, I have a tinfoil hat emote now. I'm not even kidding. Do you want to see it in the chat? We need some tinfoil. Can we just flood the chat with some tinfoil hats, please?
Love it.
But it looks like a Hershey's Kiss, but it's not. But,
I know, I believe it. It's kind of like a tinfoil dunce cap.
Yeah, kind of. I love it. Someone in my chat offered to make it, and they made it, and it's beautiful. But I know it's coming up on our hour. You've been here for an hour now. It goes by so quick.
All too fast.
Really, it does. But this is why you have to come back every week, and we hold you to that.
Next week's going to be a maybe.
Okay.
I'll warn you.
Maybe we can
I will
move
be
things
in Santa Monica, California. I'm pretty sure I'll be able to join, but I'm just not 100%.
If there's a day that works out better, send Joe that time, and I can confirm we can.
Tuesday actually is the best day.
Okay.
And it's like, it's like 80%.
Okay. All right. Sounds good. But I get to see you on Thursday.
We
talk
it's
on
go
Thursday.
Down here in Columbus. SpaceRadioshow.com for the links. I'll be sharing it on social media. It's going to be a blast.
Yeah, I just put it in there. It's the command radio, guys. That's where.
And you can call 888-581-0708 to ask Sky a question on the air.
Yeah. And we'll have that all over. I'll put it in my Discord, guys, while that's happening. So you guys have the number. I'm it's going to be pretty exciting. I'm looking forward to it. So
it's going to be the best half hour on radio that this city has ever seen.
I'd say that state has ever seen.
This state of Ohio.
Oh, yeah. Get them.
That's right. The entire Ohio River Valley.
Yes. So thank you so much. And I will talk to you soon. Everybody say bye-bye to Dr. Paul.
Bye, everyone. Thanks so much. Tons of great questions. I love your audience.
Yes. Thank you so much. I'll talk to you soon.
Take it easy.
All right. Bye. Oh, okay. Hi, guys. So that's going to be fun. I'm actually really looking forward to that. I think this is going to be the official, let's see, the second show that they've done with this way that they're doing it. And so it's going to be exciting. I'm excited. You're all blast, says Dr. Paul right there, guys. See, there he is. Paul Matt Sutter. Guys, if you type in guest, you can also find his Twitch on here. It's the last link in that huge guest command. But you can follow him on YouTube. He has live YouTube shows. And he's amazing. We love Dr. Paul. By the way, thank you everybody that subscribed while I was in the interview. I usually don't answer those, and it's not because I'm trying to be an asshole. It's just because I don't want to interrupt brilliance and customer service. I don't want to interrupt our CSR with his CSR headset. So apologies. So Jane, I don't know if you're here anymore, but thank you for the 13-month and being an amazing real life friend as well. And El Jefe, thank you for gifting a sub to Vacuum, and Skeptic to Sully. And Halatic, thank you for your sub. Bevins, thank you for your sub. And Ellen One, thank you for gifting a sub to Dr. Paul, who's back now 2 months. He probably doesn't even know, but now he has a tinfoil hat, and that's all we need to know. So I'm not done. We can start talking about other things with space if you guys want. I can answer a good amount of things, but usually I have these actual PhDs come in and answer the more difficult questions. But if anybody feels like their questions maybe not smart enough, I encourage you to ask. Yep, I'm here. There's Jane. Thank you for the 13 months. What is the Earth? Wait, what is the Earth is really just a giant potato. I bet that is supposed to be an if. And what if the Earth is really just a giant potato? Who's saying it's not? With a rotating dynamo core, this churning core of molten iron and some nickel and other cobalt. Expansion. Oh yeah, so the expansion of the universe is a thing. One way that we know this is happening is because of hopefully you don't mind my Nordic music in the background, guys. Is galaxy